Hi friends, I'm Yuvasri from second year CSEB department in Kongunadu College of Engineering and Technology. Here I am going to show the PPT and explain the topic of multiprocess systems. The short notes of multiprocess system is the backbone of the high performance computing. Here is the explanation of a multiprocess systems. The introduction is a computer system with two or more processors working together is known as an multiprocess systems. Its main goal is to improve the speed, efficiency and fault tolerance. As per the statistics, the 85% of modern servers use multiprocessor architectures. The needs of multiprocessors. The problem with a single processor is the clock speed stagnations and the more crosses. The clock speed stagnations is and Moore's law is slowing down. The more core it's used for the better performance for complex tasks. The multiprocessor benefits. There are few more benefits like speed, reliability, efficiency and power savings. Speed, it executes the multiple instructions simultaneously and in a linear manner. Reliability is nothing but if one processor fails, the other keep working. The one processor is not depend upon the other processor, so it keep working and reliable. Efficiency, it handle the massive workload effortlessly. Power savings. More cores can run at a lower frequency, reducing the heat. As per the statistics in 2023 in regarding to the Intel, the 4-core CPU scheduling is up to 8.2 F faster than the dual core CPU for parallel workload. Type of multiprocessor systems. There are majorly two types of multiprocessor systems. One is symmetric multiprocessor and another one is asymmetric multiprocessor. Symmetric multiprocessor is nothing but all processor carry memories and an input output. For example, modern desktop servers like an Intel Xeon and AMD EPYC. Use cases, database and enterprises applications. Asymmetric multiprocessor. It is a one master processor controls the others. It is examples of embedded system, older architectures in a PlayStation 2s. In real-time OS and robotics, we use this asymmetric multiprocessors. The shared memory and then distributed memory allocation. Shared memory allocation is an all processor accesses same memory and distributed memory allocation is an each processor has its own memories. The shared memory is a memory conflicts is a only major disadvantages of a shared memory, and in a distributed memory disadvantages are slower communication due to the network overloaded. For examples for the shared memories is intercore i9s and the distributed memory system is supercomputers. Parallel processing models. The task parallelism, data parallelism, and hybrid models are the major parallel processing models. The task parallelism is nothing but the different CPU handle the different tasks. For example, the web servers processing multiple requests. Data parallelism is nothing but the same operation performed on a different data sets. Task parallelism is a different task in a different CPU. Data parallelism is the same operation performed in a different data sets. For example, A and ML training models. Hybrid model is the most powerful. It is used for both the task and the data parallelism. For example, GPU is an graphics user protocols like in gaming and scientific simulation. Synchronizations. What are synchronizations and the criticals of synchronizations? It prevents the data inconsistency when the multiple process access a memories. The shared memory it is used to logs and semaphores and mutex. Slower due to the contention issues. Distributed memories use a message passing interface more complex to implement. They are the basic disadvantages for a message passing interface. The cache memory coherence. The cache memory coherence it ensures that multiple processors have an consistent views of memories. It prevents a stable data issue when the processor caches the same memory locations. The cache coherence protocol is written by the three throughputs. One is write through, write back, and MSEI protocol. First, write through is update a memory instance but increasing a memory traffic. Write back is delay the memory update for an efficiency but require an coherence controls. MEC protocol. MEC protocol is nothing but a modified, exclusive, shared and invalid used in a modern CPUs for cache management. Interconnection network. This is a bone for an multiprocessors. How do processor communicate with them in multiprocessor system? The interconnection network enable a faster data transfer between the processor and the memory. This is how it communicating between the processor to processor and make the multiprocessor systems. The type of interconnection network is majorly three type: bus based, crossbar switch and mesh torus network. Bus based is simple, cost effective, but no scalable beyond a few processors. Crossbar switch is nothing but high speed connection between a processor and a memory. Mesh and torus network is used in a supercomputer for scalability and high speed parallelism. This is both including a bus based and a cross based switch. Flynn's taxonomy. Classify the processor architectures. Here are the classify the processor architecture is single instruction, single data, single instruction, multiple data, single instructions and single data, multiple instructions and multiple data. Single instruction, single data sort of examples வந்துட்டு traditional single core CPU, single instruction multiple data is GPU and vector processing. Multiple instruction single data is fault tolerant space systems. Multiple instruction multiple data is modern multiprocessor and multi-cores. Energy efficiency in multiprocessor system. Why is power consumptions are major concerns? More processor is equal to high energy consumption and heat generation. The major technique used to improve the energy efficiency are majorly three, and they are dynamic voltage and frequency scaling, core parking, advanced cooling and solutions. Dynamic voltage is an adjust power based on a workload. Core parking is an temporarily disables the idle core to save the energy. Advanced cooling solution is liquid cooling on vapor cooling chamber, high performance and multi-core. And heterogeneous multiprocessors, CPUs and GPUs working together. What is heterogeneous multiprocessing? It combines the different types of processor like CPU, GPU, NPUs for a specialized task. For example, heterogeneous computing used in an AI machine learning and mobile processor gaming graphics. AI machine learning, the uses are GPUs and TPUs for training the deep learning models, and mobile processor is ARM big and little architecture for and power efficiency. Gaming and graphics, it combines the CPU logics with the GPU renderings. Quantum multiprocessing, the future of computing. How quantum multiprocessing enhance the multiprocessing? The traditional processor use a binaries, zeros and ones, while quantum processor use a qubits and superpositions. The computer works based on the zeros and ones is a binary digit inquiries. The qubits process exponentially more data simultaneously. Application of quantum multiprocessing. It is majorly three: cryptography, drug discovery, and AI optimizations. Where the multiprocessor used today? Nowadays, the multiprocessor used in various sectors in the real world applications as cloud computing, automotive industries, space exploration, finance and trading. They are the major multiprocessors used in the real world applications. What is the next in multiprocessor technologies? The next step of multiprocessor technology is neuromorphic computing, photonic processor, self-optimizing AI clip. Neuromorphic computing is mimics the human brains for a real-time AI process. Photonic processor is use the light instead of electricity for here instantaneous computing. Self-optimization AI clip is AI driven clips dynamically adjust their architectures for and workloads. Supercomputing and research. The real world application of microprocessor is based on and supercomputing and research, gaming, graphics and cloud computing and database. supercomputing and resource. The IBM submits a 200 petaflop computing powers. The Fugaku, Japan, simulated the COVID-19 protein interactions in gamified and graphics, ray tracing, and AI upscalings powered by parallel processing are used. In cloud computing and database, we use major managing millions of users like Google, AWS, and Azure used as SMP systems for managing a million users. Continued. Artificial intelligence and machine learnings. ChatGPT training used in 10,000 plus GPUs, all working in a parallel. As per the continuation of previous, the challenges and the feature multiprocessors are the challenges in multiprocessors majorly the programming complexity, powers and heat, cost efficiency. And the future multiprocessors are the future trends is to be changed due to the multiprocessors like quantum computing, neural processing unit, 3D stacked processors. For that, the Intel 4 stacks improve the efficiency by 50 times. The multiprocessor revolutionary computing, more processor is equal to more power, but optimizations is key. The future is parallel, AI, cloud supercomputing and beyond. Thank you for watching this PPT till the end with your smile and thank you for listening.